Hello everyone, this is example 19 on page number 344 R S Aggarwal. Okay, this is a very good question. You watch it carefully. We have to prove that it is continuous at x is equal to 0. For this clearly we have to find RHS, LHS and then function value. Correct? So let me calculate RHL. Right hand limit, right? We have to find RHL, we have to find LHL and we have to find the function value. If all these three are equal, then we say that function is continuous. So RHL, how to find RHL? Limit x is tending to 0 plus of fx. Okay, by now you know 0 plus means little bit more than 0. So for little bit more than 0, which we will take when x is not equal to 0, this one. Okay, so let me write down limit, it will be limit x is tending to 0 plus e raised to power 1 by x minus 1 by e raised to power 1 by x plus 1. Okay. First thing, whenever there is something in numerator and denominator, it's always better to use H method. Okay, whenever there is something in numerator and denominator, we use H method. For H method, x is replaced by 0 plus h. Okay, and limit is tending to 0. H is tending to 0. This is H method. Okay, let me apply H method. See here, limit h is tending to 0. Okay, this limit we have changed from 0 plus to h, and x is replaced by e raised to power 1 by 0 plus h minus 1, e raised to power 0 plus h minus 1. Okay, like this. Let's simplify. So this will become limit h is tending to 0 e raised to power 1 by h minus 1, e raised to power 1 by h minus 1. Okay. Now let's see when h is 0, so what it will become? E raised to power 1 by h. It will become e raised to power 1 by 0, and 1 by 0 is what? Infinity. So e raised to power infinity is infinity. Infinity will create a problem. So whenever we have infinity, it's better to approach in a different way. How? I am trying to get rid of this infinity term. Okay, how? So what is the step that I need to take? Write down. Divide. What I can do is divide each term by e raised to power 1 by h. Let's try. Okay. So how to do it? See carefully how to do it. It is limit h raised to power 0 1 by h. I am dividing each term by e raised to power 1 by h divided by, can you see this, divided by e raised to power 1 by h and 1 by this, here in denominator as well. Each term is divided by this. Okay, I hope it is clear. Each term is divided by this. Now let me show you one more step. After this, let's simplify. So this and this will cancel, this and this will cancel. So I will have limit h is tending to 0, 1 minus e raised to power, what is 1 by this? It will become minus 1 by h by 1 minus e raised to power minus 1 by h. Correct? Okay. Now let's put h is equal to 0 and check. So here e raised to power minus 1 by h. Here I will put So e raised to power minus 1 by 0, okay, which is e raised to power minus infinity, okay, which I can write 1 by e raised to power infinity, because this minus power I can make positive by bringing it down. 1 by e raised to power infinity is what? Infinity. Anything power infinity is infinity. Anything. And what is 1 by infinity is nothing but 0. I hope you understood this sequence of steps. Correct? So I have solved if h is tending to 0, e raised to power minus h will become 0. So let me put it here directly. Let me put 1 minus 0 and 1 minus 0 here. I have kept both sides. So answer is 1. So this is my RHL value. Okay. I hope you are done. Now I will do LHL. For LHL, what do we write? We write limit x is tending to 0 minus f of x. So which f of x we will take when it is not equal to 0? When it is not equal to 0 is this one, okay, because it is little bit less than 0. So let me write down. It will be limit, let me solve it here, 1 second, is equal to limit x is tending to 0 minus, and the question is e raised to power 1 by x minus 1, e raised to power 1 by x plus 1. Okay. Now what to do? I told you whenever there is a numerator and denominator, we usually use h method. Okay. So I am using h method, in which limit h is tending to 0, e, and x is replaced by 0 plus h. You remember why plus? I am sorry, because it is LHL. So what do we do? 0 minus h, because it is LHL. See here, this is LHL. So it will be e raised to power minus 1 by h minus 1 by e raised to power 1 by 0 minus h plus 1. Correct? Till here, I hope it's fine. Now what can we do? Let's just simplify. Limit h is tending to 0, e raised to power minus 1 by h minus 1 minus 1 by h plus 1. Correct? Now we will try to put the value of h0. In previous part, I already did e raised to power minus 1 by h. If I put h0 minus 1 by 0, it becomes e raised to power minus infinity. Correct? 1 by 0 is infinity. And I made it plus by bringing it down. 1 by e raised to power infinity. Anything power infinity is infinity. So 1 by infinity. And 1 by infinity is always 0. Okay. So you should always remember one thing, guys. If there is 1 by 0, it is infinity. If it is 1 by infinity, it is 0. These two things you should know. Okay. So for now, I know that if I put h0, this term I am getting 0 minus 1. This one I am getting 0. And this is also 0. 0 plus 1. What is it? 0 minus 1 and 0 plus 1 is minus 1 by 1, which is minus 1. So my LHL is a minus 1. Okay. Now I will check the function value at 0. So if you see the question, if you observe the question, f0 they had given in the question itself. Here, the function at x0 is 0 itself. So the function value I know, let me write down, is 0. So you can see clearly everything is coming different, right? RHL came 1, LHL came minus 1, function came 0. It is totally discontinuous function. Okay. So its limit does not exist because RHL is not equal to LHL and it is completely discontinuous. Let's do next question. So let's learn some rules. Following functions are always continuous, like sine function, cosine function, log function or function of functions. They all are always continuous. So if they have given say they have given sine of cos of x function, okay, so this will be a continuous function because sine function itself is a continuous function and cosine function is also a continuous function. So sine of cosine will also be continuous because they say function of function is also continuous. Now we will do example 1. This is example number 1 at page number 353 in RS Aggarwal. So they have given this is a function and we need to check whether it is continuous or not. They are not asking to check continuity at 1 only. They are asking to check continuity at 1, before 1 and after 1. It can have any number before 1 also, after 1 also and at 1 also. If function is continuous at all the points, then we can say it is continuous. If we are able to find even one point where it is discontinuous, then we will declare that function is discontinuous. So we will check continuity at 3 possible points. At 3 points. What will be those points? At x is equal to 1, at x is equal to any number less than 1, and at x is equal to any number at more than 1. Okay, so we will check in 3 cases the continuity of the function. Means what is happening in the function before 1, what is happening after 1 and exactly at 1. If at all 3 cases function is continuous, we will declare that it is continuous. So it will be a little bit lengthy question if they are asking in general whether it is continuous or not. If they are asking the continuity to be checked at 1, then it is a very straightforward question. You can just check it at 1. But now we have to check at 1 also, less than 1 also and more than 1 also. Let's continue to do it. I am taking first at x is equal to 1. So I am checking at x is equal to 1. So let me take 3 possibilities. Okay, we take LHL, let's take RHL and then take the function value itself. So LHL is limit x is tending to 1 minus little bit less than 1. So which function we should take? Which one? Little bit less than is this x square. So this one I will take. Put one value, 1 square is 1. Now RHL limit x tending to 1 plus little bit more than 1. So what should we take? Little bit more than 1, I think, is this one, is x. Just put 1, so it is 1 only. And what is functional value at 1? So when it is equal to 1 will be this, which is x. So x is equal to 1, the value is 1 only. So here we end up having clearly LHL value, RHL value and function value all are equal, correct? So it is continuous. Clearly RHL is equal to LHL is equal to function value. So I can say that it is continuous at x is equal to 1. So 1 point is not a problem. But we have to make sure what the function is doing before 1. Means say the point is 0 or the point is say minus 1, minus 2, minus 3. There is some general point. Okay. So let me take I will explain it with one example, any number, but we can take, okay, let me explain with some general number. Say x is equal to, let me take x is equal to a, any number a which is less than 1. Okay? So let me take x is equal to a, where a is less than 1, means it is somewhere here, it is somewhere here, some point less than 1. Okay, a is less than 1. So at a I am checking, so LHL will be a minus, correct? For RHL I will be interested in x is tending to a plus and functional value I will be interested in f of a. And remember, a is somewhere here, a is less than 1. In your brain you can think a is say 0. In your brain, you just keep it in your brain that it is 0. So a minus matlab less than 0, because I am assuming it is 0. So less than 0 is less than 1, of course. So which one should I take? This one only. So let me put here x. X is equal to a, you put, a is the answer. This is LHL. Correct? Let me try for I am sorry, here a is less than 1. So less than 1 के लिए we will use this one. Less than 1 is this. So functional value is less than 1 is x square. And x square, when you will put a here, x is equal to a, we will get a square. So what we are getting here is a square. This is for left hand limit. Now right hand limit, f of x, a plus. So keep in mind, a is a number which is less than 1. So we will take somewhere here, this one less than 1. To limit x is tending to a plus x square. And if you put x is equal to a is a square. Here directly we can put the value. No need of h method, because it is just a polynomial function. H method is used in a very special cases where we have some function fx by gx, we have trigonometric functions, or we are having some values of limits like 0 by 0. In those cases we use H method. Here there is no need to use H method because it's a plain polynomial functions. Now fa, the functional value at a itself. So which one should I take? Again less than 1, because a is nothing but less than 1. So it will be a square, which is a square. So again I am having all three values equal. LHL is equal to RHL is equal to function value. The function is continuous even when it is less than 1. So we can declare that function is continuous when it is less than 1. Correct? It is continuous for x is less than 1. Let's test it for what the function is doing here. When the function is going above 1, what it is doing here. So I am trying to check the function at x is equal to a. And what is a? A is more than 1. Okay? Because we need to know what the function is doing beyond 1. So this is LHL, where x is tending to a minus, RHL, where x is tending to a plus, and f of a. So let's do LHL. So LHL, so I need to put a more than 1 and a minus, suppose a is more than 1, say any number more than 1, say it is 5. So 5 minus, it will still be more than 1, right? Any number which is more than 1, if I take little bit less than 5 here, it will still be more than 1. I hope you understood. For limit, we stay very close to 5, little bit less than 5, which is still more than 1. Correct? So which one should I take in definition? This one, more than 1. So which is x. So now put the value is a only. Here 5 plus, you see 5 plus, which is still more than 1. So I will take again this more than 1 equation. This is x. So it is again a. And f of a, where a is a number more than 1. So I will use this only, x. So x is equal to what? A. So a. So here also we can see clearly LHL is equal to RHL is equal to f of x. So can I declare that it is continuous? The function is continuous. Fx is continuous at x is more than 1. So in all three cases we found it is continuous, less than 1, more than 1, or at 1 itself. So that means function is, what is the conclusion we got here? Let me write down. The conclusion here is fx is continuous everywhere or all values of x. It is continuous at all values of x. See you in next video.